Okay, so I'm going to erase this thing. This is not working. We are doing in the wrong way. But now, okay. So
So you're showing the first one.
Yeah, first one, second one, anyone. It's a hint only. I'm going to give you a hint. Okay. So okay. So what we have here, we have three variables A, B, C. For plus, what is logical diagram for plus? We have something like that. No, it comes here from A and B. When we draw like that, then this is for plus. Yes or no? For dot, what we have? So two inputs. How one can do a dot is D only. Yes or no? Then output. And for not complement or dash, for suppose A dash, we have A. The starting point is this. Then we have triangle. Then we have. Yes or no? This is what we have. Yes or no? Am I audible?
Yes, sir. Yes, it is.
Okay. So now what we have three inputs A, B, and C. So I just draw my three inputs. So this is nothing but I have A. This is nothing but I have B. This is nothing but I have C. Okay. Then we have A and B. We have plus here for A and B. Okay. So for A and B, just try to draw a plus sign. So we have output of that plus. Okay. Then we have dot with A plus B complement. So we also need A and we need B. Okay, so for that purpose, we need to rearrange that. So what I'm going to do, I'm going to rearrange that. So I just write down B here, A here, and C somewhere below. So I write down here, C somewhere here. Now what I want B dash. So B dash is nothing but the complement of B. So I get here I will get B, but what I want its negation. So I started with the negation here. Okay, I'm getting that negation. Then what I want A. So I have A here. So again I get A from here to here. Okay, and I want the product of these two, A plus B. What I want A plus B. So we have A here, we have B. This goes like that, no problem. So then we draw here. Again, you can draw like that, no problem. And what we have plus here, plus is nothing but what? Here. Yes or no?
Sir, can you tell?
Not here. Wait a minute. Yeah. Yes, please tell me why.
It should be ABC, right? For
ABC, yeah. ABC, BAC, it's just the input. A is
okay,
input. You can write down
the
ABC.
diagram is same. Only we have just arranged the.
Arrange ABC accordingly. You can
Okay.
arrange C first, B second, D, whatever you want. No problem.
Okay.
So whether here B dash it comes, okay. Now what we have? So now this is my rough diagram. You need to draw a clear diagram by interchanging A below B here so that no one will intersect like that only. So this is done. Everyone understand A plus B dash plus. So here B dash I am getting. Here A I am getting. Its plus I am getting. Its product with the D. So what we have here, its output and its output we have for the D1. Okay. Now we just have this problem. What I have to do for this output? So I have this output. Okay. And I have to do output with that A plus B. So we have A plus B here like that. So this is my output. I need to arrange that, do the dot product of this and this. So, and then you will get that one. You are getting what I'm trying to say.
Sir,
Yes.
sir, why you have taken that first one as like semicircle?
This semicircle for
Yeah,
D.
A and B.
For
A
dot we have D, no? O, A, B, we have dot. No, it's not semicircle. I think I have, yeah, here also we have, yes. It's not like that, correct. We have here that, it's not dot, no? So we have something like that. Okay.
Yes, sir, clear.
Now got it? Now do that product. Now, while doing this, that's why, while solving such examples, you need to evaluate that example further. And for that purpose, we require some laws. Okay. What are law? What is commutative law, absorption law, what is De Morgan's law, and every law. So today we are going to discuss this law first, and then we will go for such kind of examples. Here also, it is easy. It is not that much of fun. Now my problem is what how to tackle this one, because here we are getting too much complications here. Instead of doing this, if I try to solve this law by using, like, if I multiply that C inside and B inside, see what I'm getting, a very clean and clear equation. That time we will again try to draw a same diagram. Here also three inputs A, B, C. So you can start with here A, here B, here C. What we have for A and B, you have dot first. So AB you have dot, so you can draw D here. Then what you have again B dash and C. So we have C here. So I just go here with, this is nothing but B dash I am getting, and again C. So I am getting C, and I am getting a dot here. So here also I am getting dot. Okay, then we have C dash A dash. So C dash. So A is here. So again, see here, if I wanted to find first A dash. So I wanted to take like that here. Here I am getting something. A dash is nothing but triangle and 0. This is A dash. And I am getting here again C dash. And then we have to do the dot. So we have dot here. And then combinedly we have sum. So first we have these two sum, then we have these two sum. You can, for sum we have something like this. No? This sum, and whatever the sum I am getting is this sum I am getting like that. So sum we have like that. Got it, everyone? This is hint. Yes or no?
Means these are the hints for both. This,
Yeah. So we have first add these two, whatever the answer I am getting. So this and this D and this D. If I add this, and again whatever that answer I am getting, I am adding with this. So again I am going to add. So this is what you have the diagram. But this is
sir, can
easy.
you shift the screen to the right? I couldn't see that after that.
This one you are
See,
talking about. This one you are talking about. This is what we have. This is when you are talking about. I have to take here. Got it? Am I audible?
Yes, sir.
Okay. Okay. So now we have different rule when you cross the line, such that we have crossed the line. So you need to draw something like that. Okay. So we are going to,
Sir,
yes.
sir, means to draw these gates. What question will they ask? Means draw the gates.
Draw a logical diagram
Okay.
for simple one like that. Okay. So for first one, we are going to see, after simplifying what we are getting, we are going to see this one. For second one, we have like that. We have A, B, C, then how A goes, how B goes, how D goes. This is just the revision hint. We are going to solve this, all the problems in detail. Once we're done with the all different laws. Once we're done with the laws, then we will go further. So let's see first how that law will work. Then we will go further. So we already done what is mean by AND gate, what is mean by OR gate, what is mean by NOT gate. Okay. Now we require these gates actually, AND, OR, and NOT gate. Okay. So first law, write down a commutative law. So what is commutative law with respect to and with respect to OR? So first one,
With respect to oral,
1A plus B, what this will give you for commutative? B plus E. Yes or no?
Yes, sir.
And for with respect to and A dot B will give you B dot E. Okay. So this is what we have commutative law. Right on that. You can find out the truth table. That truth table also comes in this way. You will get the same truth value for LHS also, for RHS also. Then associative law. These are the basics ones, so I'm not going to take too much. I'm not going to waste too much time on that. Associative law. Yes. Tell me, what is associative law? With respect to first OR get A plus B plus C. What is A plus B plus C?
A plus B bracket plus C.
A plus B bracket and what you are getting plus C. And the second one with respect to dot A dot B dot C, you are getting A dot B dot C. Okay, these are very quite simple and you know already this one. Now important distributive law. Same law we have done in a group theory also. Okay, what is distributive and everything. So with respect to, so here we have two. Okay, here we have mixing. Okay, so first A dot
B plus C.
B plus C. Tell me what it comes. A dot B plus C.
A B plus C.
plus B dot C.
No. How?
A B plus AC.
A dot B and A dot C. Like that. Okay. You multiply this inside. A inside, so AB, that plus as it is BC. That is the first one. What is second one? A plus BC. Here it is interesting. Yes, can someone tell me what it comes? So for that purpose, we required one more law, idempotent law. So what is idempotent law? So first we discuss idempotent, then we'll go further. Okay. So then you will realize that. So write down idempotent law. Idempotent law. So what the law says that the law, anyone knows what is idempotent law? Idempotence law. So it is nothing but A dot A will give you A only, and A plus A also gives you A only. You can try to draw a truth table of that, no problem. So just try, we will verify that. Suppose I have A, only one variable. So either I have 0, 1. So again I have A. So again I have 0, 1. So no, how one can calculate. So A, if I add in A, we have only two combinations, no? So A into A. So what you are getting? Same 0, 1, 0, 1. So again you are getting 0, 0, 1 like that. So this, why we need to draw a table only. You are getting the same thing. You can understand that two law. Now tell me, what is distributive law for this? If we have idempotent law with you. Idempotent means what? Same value. Idempotent means same value. Okay. So adding a variable here in the second one, adding the variable with itself will always give you the same variable. And here, adding the variable, dot is nothing but plus is nothing but and dot is nothing but or. So adding the variable with respect to itself will give you the same variable. That is what idempotent. Now tell me what will come here.
A plus B
A
bracket plus B
plus B, very good.
dot A plus C.
A plus C, absolutely correct. So whenever you have such kind of A plus BC, you can write down that A plus BC in the distributive law, A plus B. Why? Why? Because once you try to solve this, so if you multiply this inside here, so A into A you are getting A into A. Okay, then you are getting A into this you multiply here. Now this you multiply here, this you multiply here. What happened? What happened? Whether it's correct?
So what about AB and AC?
Just give me a minute. Give me a minute. If I try to sign AA come here, then AC, then BA plus BC. So this becomes A. What happened with AC and BA?
Hmm.
How this get cancelled? You can take A common. What you are getting? B plus C. Okay, no, like that only. No? Yeah, yeah. Okay. So what we are going to do? Everyone understand up to this? So try to
Sir,
solve
can you
it.
tell how did that A plus B into bracket A plus C came using
Yeah,
this
yeah, yeah, yeah,
idempotent law?
yeah. Simple, no. What is? That's why I'm verifying that. So we have A plus BC. So I just write down here A plus BC by idempotent law. It is true. Okay. So
Yes.
what I'm going to do, I'm going to show that now I have this thing with me. So if my this is correct, so I just try to solve this one. I'm getting this to that side. So what I'm getting, so we have A plus B dot A plus C. So if you multiply what you are getting AA, correct? What is next? Tell me.
C
Plus
AC
AC.
plus AB plus BC.
BC.
So from this I can take AA. So I just write down AA plus BC. What I want BC I want. Okay. Plus AC plus AB. Okay. So here. How if I take A common out, so what I am getting B plus C. Yes or no? And
Yes.
here I cannot take anything common.
Here we can take only A because A is equal to A.
Sir, can I explain?
Yes, please.
So from AC plus AB, we can take A common.
Okay. I will do that only. Let's check it out.
Like keep as it is the term AA
Okay,
and just
A as it is. Okay,
and BC also as it is.
A I take I take a common. So what it remains with
C plus B.
or B plus C because it
Yeah.
is commutative and BC
Now
as it is. Yes.
take common from AA plus A bracket B plus C, A common. Yeah, from this
Okay.
term.
So A plus B plus C plus BC. Am I correct? If I take A common, what remains here? A plus that A already common, B plus C as it is, and plus BC. Am I correct?
Yes, sir.
Then how distributive law this equation becomes this? Oh, okay. If I take, I want A plus BC, A plus BC. So A plus BC I am getting here. Exactly. But. Okay.
So A into 1 is A. So
Correct.
instead of A dot A, we can take A into 1. Like it will be easy for understanding. Like if we take A common from A common, then it will be 1 plus B plus C.
1 plus.
B plus C. If we take A common, like if we take A into 1,
Yeah,
that is
exactly.
A.
You are saying 1 is here.
Yeah.
Instead of here, A is A. So like that only you are talking about. So 1 plus BC, yeah, correct. Then also problem is not solved. How we are getting this now? That is the question. Whether we are doing correct multiplication, because not get multiplication is allowed, no problem. No problem at all. No problem. So if I take this common, okay, we will go in a different way. Okay, we will try to go in a different way. From LHS to RHS, we will try to go. Let's see what happens. We need to use some identities there only. So what we have, A plus BC. Okay. So we have 3 factors. What I want, A, B, I want. So A plus BC I can add here because A is
Instead
idempotent.
of taking A dot A, you can take A dot 1. So it will be easy for understanding too.
Yeah, A dot 1 is also there because I'm using this now idempotency. A dot A is equal to A. Again, I think some internet connectivity issue. It's visible? It's visible to everyone?
No, sir, not yet.
Oh. Sir,
Yes.
As I
so
got
for
it.
that, if for that, like for to prove that, we will have to do truth table. Then it will come easily.
For
Like
truth
first we
table,
have,
it's come true.
yeah, it comes true.
Yeah, but okay. Yeah, maybe.
I have got
Because it's these are Boolean algebras,
got
right?
where we
So
have
one
stuck.
and one zero.
No, but what is my point? Why we are not getting after solving by using this one? For truth
Sir, I
table,
got it. I got it.
yes,
Where we
please.
stuck. Sir, anything or operated with 1 will always be 1. So
Okay.
1 plus B plus C will always be 1.
So
Like B
one,
plus C, B plus C is equal to, it is in one bracket, and 1 plus B plus C is like B plus C is in another bracket and 1 is in another bracket. So anything or operated with 1 will always be 1. So
Okay.
A dot 1, and we'll get a plus BC. So A plus BC will hence proved. Like,
okay. A dot 1 plus BC. That is what we are seeing. What is next then?
no, sir, if we take A dot A, that's also fine. But
Okay.
if we are doing through this method, we can
Which- Give me the
from
first
this-
statement. Okay. Shall I start with this one or this one?
from RHS we can start, no, sir.
Okay, left hand side. Okay, we start with the left hand side. Then
RHS, sir.
Right hand side, sir. Right hand side.
yeah, A plus B. Yes, no. A plus B dot A plus C. Okay, what is next?
So next will be A dot A
Okay, A dot A
plus A dot C
plus, okay, A dot C.
plus
plus C.
like, yeah, the plus A dot B plus B dot C. No, not the bracket, sir.
Just wait. Okay, I'm getting in another way. Whether I'm getting or not, I will check it. So what I'm trying to do, I just multiply that A to whole bracket and this to whole bracket, and then I will check whether I'm getting or not. Okay, so what I'm getting, A into A plus C, something like that, plus B into A plus C. Okay, but we are getting same thing.
Yeah,
Okay,
sir, that's what.
Hmm.
So we can do like before we have done A dot A plus A dot C plus AB dot plus BC. So we can take A common from B plus C.
Okay. I will go with what you are saying. Just give me a minute. I will write down here so everyone understands. Just tell me what I write. What should I write here?
A dot A
A dot A
plus A dot C
A dot C
plus A dot B
A dot B
plus B dot C.
plus B dot C.
Yeah.
Okay.
And from AC plus AB, we can take A common. Keeping
AC
A dot A,
AC to
AB, we can take A common.
yes. Okay. So what is
Keeping the
remaining?
same, we can keep A dot A as the same and B dot B as the same way.
So what I am getting B plus C. Is it okay?
Yes, sir.
And plus BC here. Okay. What is next?
Again, take common A from A dot A plus A bracket B plus C.
So you are talking about take A common from here.
Yeah, yeah.
What
So
we
we
are
can
getting?
get one A plus B plus C
A plus B plus C.
plus BC.
I have very unstable connection. Just give me a minute. Whether the screen is visible now?
Yes, sir.
What is next now? Yes, please tell me.
Sir, instead of A, we can write 1. Like A dot 1 is equal to 1. A.
Where you are talking about this A, this A. If you multiply inside.
In the bracket, which is A plus B plus C, we can write, instead of A, we
One,
can write 1.
Here,
Yeah.
here, yeah.
So
Okay.
anything or operated with 1 will always give 1, right?
Okay, so you mean
So
to
it
say-
will
yeah,
be
yeah,
A
correct,
dot
correct,
1 plus BC. So it will be A plus BC. Hence proof.
correct, 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 correct. Very good, very good. Yes, yes, yes. So for that purpose, we need to write down that property also. So well, I think we already did, no, that property. De Morgan's law. Dual we have written. Okay, we have duality and gates. Okay, yeah, correct, correct. Everyone understand? Every other one understand that?
So means instead of writing A in the bracket where
No,
A
no.
plus B plus C,
I will
you have
explain that.
written 1.
Yes. Why this so? Because if you have one, and you take or with anything, whether it has 0, 1, whatever you have, you can take anything here. The answer is always 1. I'm talking about or. So whatever we have 1 plus A plus 1 is always 1.
Okay.
Okay, so what we have here, what she is saying, and she is absolutely correct. So I just write down in good manner, so you will understand that. So I take A common. So here A is nothing but only A. So I write down A here. Again we have A here. So I write down A here. B plus C as it is plus B plus C. Now I can take A common. So if I take A common, what remains here? 1 plus. That A already gone. What remains here in the bracket? B plus C. And what you have here? BC. Now you are adding 1 to any number. So we have this property with us. A plus anything is always 1. So 1 plus anything is always 1 only. So A, here you are getting 1, and which is BC. And you are getting A plus BC. That is what required thing. If you start with this and you are getting this, that's why this is true. Got it, everyone now?
Even from truth table, we can
Truth table, yeah.
prove.
Truth table is the easiest way. But you know,
Yeah.
I want this statement like that only because sometimes whatever our next problem we have problem by using these properties. Because when we have 5 variables, 6 variables, that time truth table is very big. So instead of finding such a truth table, we can find by using this. Okay? Using truth table, you will get it. Definitely, you will get it. Okay? The
Yes,
next
sir.
one is the 5th one. Absorption law. So what is that one? So now you just try to solve this. A plus AB will give you directly A. Now try to find the proof. How it will come?
So
Sir,
instead
maybe
of C, just
Same
A
thing.
is there.
Same thing.
will-
Same
yeah.
thing. LHS. So what you are going to do? A plus AB. You can take A common. You will get 1 plus B. What is 1 plus B? Is 1. So you are getting 2. Yes or no?
Yes, sir.
Okay. And the next one we have in that the same one. What is this? A into A plus B, which is also A. Can you solve that one?
it will come A only, but only the operation is different.
Operation is different means?
No, means in last. Means
Yeah.
A dot
The
A
proof.
plus B, like that I'm
Yes,
saying. Yes.
yes, correct, correct. You can find out in that way. Why? Because this is just another way. Because if you multiply that, so once you multiply that, what you are getting? A into A plus A into B. Am I correct? So A into
Yes,
A
sir.
is again A, and you are getting again here AB. So what you are getting? You are getting this term. And by using this, you can write it down. It is A. So this is called as absorption law. Okay, it's absorb that B. Okay.
Sir,
Yes.
means just like we observed or looked at the distributive law and absorption law, we need we needed idempotent law, right?
Yeah, we
Because
required. We required. This is also important point. This is just I'm not going to now explain whether it forms some group or something like that. This you can interchange the sequence, commutativity first. It is not the some sequence kind of. This is always there. This law is always there. This law is also always there. Okay, so idempotent law is also required. So why we required this one? Because right now we have a big statements. We need to check what is the output of that statement. By using truth table, it is not possible. Just like we did here. Now this is very big statement. No. So if I use here distributive one, if I try to use here distributive one, so I will check what I will get here. So instead of solving, I will get that some example, and finding the logical diagram of that sum, it is easy as compared to this one. So that's why we simplify the given Boolean expression. For that purpose, we require this law. Got it? So whenever you have suppose AB plus AC like that only. So instead of finding AB and AC, finding the diagram or finding the truth table or finding this, it's very easy to find directly this. Yes or no?
yes,
While solving the expression, I will give you that example as well. I will give you examples on expressions also. Here also see, when you have A plus AB, so you directly know the answer is A only. Why to find B, whatever the value of B, you directly get the A. That is the beauty. That is the beauty of this thing. Got it? Everyone?
yes, sir. Means it will
Okay.
happen quickly. That
Yeah.
solution will get it quickly.
Very quickly. Without by using this law, you can find out your output in minimum steps. Because
Okay.
in computer science or in any computer thing, the minimum solution is most important. Optimum solution within minimum steps. Because even if you have a supercomputer and everything, that time if you the finding the prime number, it will take a half hour. It's not that much of feasible. So for that purpose, what is the way? By using that way, you can find the solution in minimum steps. That is most important. The minimum steps are most important. Okay, so we have an example, some examples. So now De Morgan's theorems already I have discussed. So I will again give you here. What is a complement of complement?
A.
That is simple. That you know already. Okay. That is there only. That is very easy. That we know already. Now what is De Morgan's law? So yes, De Morgan's law, I think we have discussed that one.
Yes, A plus B bar is equal to A bar dot B bar.
Which is equal to A bar dot B bar. Okay, and the second one we have exactly opposite. B bar. So that is what we have for the. Yeah. Now let's try to solve the examples. So this is one. This is some example also. Can you simplify that? AB plus A bar C, which is equal to A plus C and A bar plus B. Whether this statement is true. Now you have two ways. Either you can find truth table of LHS, truth table of RHS and check it out whether these are equal or not. Yes or no. And another one, you can try to solve this one. So how one can solve? This law is called as transposition law. Transposition law. Can you get this one? Yes, anyone? Can someone will find out? You can start from LHS to RHS or RHS to LHS, no problem.
Sir, if, we can start from RHS, that we first
problem.
need to multiply the brackets.
Yes, we can do that. So A plus C.
First, it will come A into A bar, means
What is A into A bar? Yes, I write down.
0.
A into A bar. Then what is next?
Then
AB.
AB plus A bar C
A bar C plus
plus BC.
BC. So what is this?
0. A into A bar
0. 0 plus AB
plus AC bar plus BC.
plus BC. So here 0 plus you are getting only because plus is there. Now if you add, you get the same thing. Yes, what is next?
Then from I think
Now
from
what
AB.
you want?
We can take B common from AB plus BC.
Because what I want here, A bar plus B bar I want. No.
We can keep A bar C like
As it is.
aside
Okay.
as it is,
And we can
AB
take
plus
B
BC. A B common, then it will be A plus C.
plus A bar C. Is it okay?
Yes, sir.
So I got AC. Okay. Now I also want here AC. So what I'm going to do? B into A plus C plus I want here A also, no? So what term I should manage here so that I will get. So here we need to use the absorption law also may used. So we need to check it out that this one. Okay, so tell me.
So
Yes, yes.
can I say after the third step like AB
Yeah,
plus,
you can. No problem. No problem.
okay, so after that AB plus A bar C plus BC
Okay.
equal to AB plus
AB plus
A bar C
A bar C
plus BC1
plus BC
1.
into 1. You are
Yeah.
saying. Okay, no problem.
Yeah. So next step
Hmm.
AB plus A bar C plus
AB plus A bar C plus
BC,
BC.
and in bracket it would be A plus A inverse
Okay, you can do that also. No problem.
plus. So plus, not a dot.
Ha,
Then
if
it will
you
be
take the
zero, na?
plus for plus, I will
A
get yes,
plus,
correct.
yeah.
I will erase that. Just give me
Then
the-
we will do distributive law
just give
that
me
will
the
multiply.
A plus E bar. Correct. Yes. What is next then?
Then we'll multiply like AB plus AC plus BCA plus BCA bar.
This term I kept as it is. And if I use distributive, so I am getting A, B, C, plus
plus
A bar
A bar
BC.
BC.
Okay. Now what I want? Now A plus C I want. So A and C I want. So here if I take A
So-
common out,
Then yeah, then we'll do like we can arrange it in the order from where we
like
can
that
take
you are
the
talking
common.
about, no?
Yeah.
So
Yes.
if I take from this, if I take A bar as a common,
Hmm.
so what remaining with I have A, so C plus
Plus BC.
CB. Am I correct?
Yeah. Yes.
And from here I can take also a common B. So I'm getting A plus AC. Yes or
So
no?
instead, no. So don't take A common, now take AB common.
Common, yes,
From-
sir.
Yeah, I will take now. What is in my mind? I will use here simply. Okay, you can take that also, no problem. So same
Yeah,
bracket
instead
will
of
come. Yeah,
Instead
same
of
you
A, take AB only common.
exactly. So you need to make a bracket same so that instead of
From
if I
AB,
take
like from AB and ABC, we'll take AB common. So
Will be 1 plus C.
is it okay?
Yeah,
From
and from
that bracket.
AC and from AC plus A by BC, we'll take AC common, A by C common.
Okay, okay. So instead of from first bracket, we will take AC common.
AC common, yeah, like A by C common.
So if I take here A bar C common, so what remains 1 plus C. AC B
1 plus B, yeah.
1 plus B. Okay, what is next then now?
Now anything, if we add with 1, it comes 1 only, no?
AC and
Like AC under 1 plus B.
yeah, AC
Did you
plus
write
1
this?
plus B, which is 1, no?
Yeah. Actually, my screen shows that is that. Yeah. Then after that,
Yeah, so
Done,
you are
done.
started, yeah, you are started with where you are started from RHS, this side.
yeah.
And what you are receiving this, and you can write down it is commutativity. So AB plus
Plus,
A bar C.
yeah.
2. So see, by using truth table also you can find out this one, no problem at all.
Sir,
Yes.
can you tell the third last step AC
Okay,
bar
okay.
into 1
I
plus
will
B?
explain. I will explain everything. Okay.
Okay.
So first we take a bracket, simple one. We do the multiplication inside. We will get this one. Now we know that a dot product with its opponent, its inverse. We can say that. Okay.
Okay.
So
Or
it
its
will give you
opposite.
0. So this is simply remains. And if you add 0 to anything, you will get the same thing. Okay. So
Yes.
from here, what I did for BC, I make one arrangement. I add that one. A plus A bar with the dot. The value of A plus A bar is 1. So 1 into BC, I'm getting BC only. Now if I multiply this inside, what I'm getting this term as it is. So BCA, so ABC, because it is commutative, and A bar BC, it is commutative. So up to this step, I think there is no problem. Now,
Means we just multiplied that
yeah,
one with
BC
BC.
inside.
Okay.
That one is nothing but A plus A bar.
Okay.
And I multiply that BC inside. So once I multiply BC inside, I should get BCA, but it is commutative. So BC I
Yes.
can write down ABC. And same thing we did here, A bar BC. Okay, so I think everyone got this. Now from these two, I have this one and this one. I can take A bar C common. So if I take A bar C common, what remains here? This already gone, so it remains 1. Here A and C taken outside, just remain with the B. So 1 plus B. Similarly, whatever I have remaining, that third one, I just underline 3 lines. I can take AB common. So here 1 and here C. Okay. So 1 plus anything is always 1, and 1 plus anything is always 1. So what I'm getting? AC plus BC. That is what I'm getting. A plus B, A bar plus C.
Okay.
Got it? So this is
Okay.
also called as transposition law. So no
Means
need
this
to.
third
This is the
last
proof.
step
And this is
means
nothing
this
but
third.
what? AB plus AC. This is nothing but your LHS.
Yeah, means that third last step came because we took A bar C common, right?
Yeah, here, from here. No, not 1 plus B. 1 plus b is what? 1 plus anything is always 1.
1.
And 1 plus anything is always 1. So this value is 1, this value is 1. So a bar c
Okay.
remains as it is, ab remains as it is, and I just use commutative law again. So I will
Okay.
get this one. So this is the proof of that statement. Okay, no need to write down the proof, but you should know this law. Now whenever we have ab plus a bar c, you can directly apply transposition law here, like that only. A plus c, a bar plus c. So we will get that thing. Okay, got it everyone?
Yes, sir.
Now I'm going to give you some example as a homework by using these all laws, that's 7 and 8 laws. Which one? First one is commutative, associativity, distributive, idempotent, absorption, De Morgan's, and transposition. And
So
this is
write
one.
those rules also, not that one. A plus A inverse is equal to 1 and A dot
Okay,
A
okay,
inverse
okay. I can write down that ninth one. Okay.
Yeah.
Tell me which you need. So
A
a
plus
plus 1 is always 1.
is 1, yeah.
10.
And
A
A
dot 1.
plus
What is a dot 1?
A.
You are getting 8 itself. Very good. 11. What is next? Dot the A.
Plus A inverse
A plus A inverse. Yes, tell me what you are getting. So you can
1.
easily find out. You are getting always 1 because it is alternate. No. Then next. A dot A
A
inverse.
dot A
A
inverse.
inverse equal to 0.
100% you will get the 0. Okay. Now what remains?
Alternate.
0, 0 remains. No. A plus 0. What is A plus 0?
A only.
A only. And next one is A dot 0.
0.
0. So these are the basics law. Okay. So you can keep that law in also in your mind. That all 14 laws. Okay.
Yes.
Okay. So I'm going to give you some example. You need to check it out. I'm going to ask just such an example as an MCQ. So Boolean expression. So number 1, the Boolean expression. The Boolean expression. The Boolean expression. A plus B in first bracket, next bracket, B bar plus C and C plus E can be simplified. Can be simplified as number 1. Now I have given 4 options. A plus B in first bracket, next bracket, B bar plus C. In second, we have A bar plus B and B bar plus C. C, we have A plus B there and B bar plus C. And for D, we have A plus B bar and B plus C bar. Okay, that is first you have one example. Now you need to check it out. Everyone understand no? How one can do it? First, second, third, fourth, you can find out whether it is equal or not. Okay, and the next example, we have A bar dot B bar dot C bar and whole bar is equal to. Again, option A. Can someone tell me what it comes?
A, B, C.
Let's see which option will become here. Option third. Option 4. A dot B dot C. Yeah. Tell me.
It
Which
will be A dot B dot C, I think.
Okay. Any other person who wants to say something? Someone is saying A dot B dot C. So
Option
D.
D.
Everyone is saying option D. Okay. Okay. I don't think it's D. You are not getting. Your voice is breaking, I think. Yes. A. A is also, I don't think A is correct one. Do it, think on that, think on that. I think what I feel, it will come C. Check it out. We will discuss this in the next lecture. Okay. And try to solve that first example. This Boolean expression can be simplified. Okay.
Yes, sir.
Okay. Just give me a minute. I will take the attendance.